For this series of lectures, we will continue to look into the use of digital tools in construction. Let's look into the use of robots in construction. We call it the robotics. The use of artificial intelligence in the construction industry. We call it AI, as well as blockchain usage for construction. Let's talk about robotics first. The construction industry is one of the most labor-intensive industry in the world. Yet, due to the continuing labor shortage, the industry has needed to adapt to a lack of people who can do this labor. Adapting has always been one of the industry's strongest skills, and with technological advancement occurring every day, a new solution has developed: the use of construction robots. Economists analyze long-term trends around the uptake of automation in the workplace, noting that the number of robots in use worldwide increased threefold over the past 20 years to a total of 2.25 million robots. While researchers predicted the rise of robots will bring about benefits in terms of productivity and economic growth, they also acknowledged that the drawbacks that were expected to arise simultaneously. Robots could take over 20 million manufacturing jobs around the world by 2030, economists claim in a study. According to a new study from Oxford Economics, within the next 11 years, there could be 14 million robots working in China alone. Some researchers pointed out that as a result of robotization, millions of jobs could be lost, especially in poorer countries that rely on lower skilled workers. This will therefore translate into an increase in income inequality, claim some researchers. However, if robots installation were boosted to 30% more than the baseline forecast by 2030, some researchers also estimated that it will lead to a 5.3% boost in global GPT that year. This equates to adding an extra $4.9 trillion per year to the global economy by 2030, which is equivalent to an economy greater than the projected size of Germany. According to some reports, the number of robots installed in workplaces in the past 4 years is the same as the number put to work over the 8 years previously. Approximately every third robot in industry is now installed in China, researchers found, with the world's second largest economy accounting for around 1 in 5 of the global stock of robots. It was predicted that by the year 2030, more than 1.5 million jobs would have been lost to robots alone in the United States. In China, that number was expected to exceed 11 million. Across the European countries, almost 2 million people would lose out on employment because of automation, the report stated. These are some of the ways for us to classify the construction robots. We can lump them as industrial robots, where they are doing the work in the factory, or we can lump them as drones, or classify them as self-driving construction vehicles. And lastly, there's one category called humanoid laborers. Let's look into detail on all these 4 categories, starting with industrial robots. Industrial robots used in the manufacturing sector are some of the more well-known examples of automation that has been taking place for the past 50 years. As construction technology continues to advance, the industry has seen an increased use of robotics in order to perform repetitive, high-value tasks, increasingly in the prefabrication yard, for example. Let's look into some common uses for industrial robots, starting with manufacturing with articulated robots. Articulated robots are robotics used in manufacturing. They closely resemble a human arm and are used for a variety of tasks and applications. The use of an articulated robot ranges from simple assembly to welding. In fact, articulated robots are so versatile, they are being used for space construction. For example, the Canadarms are robotic crane attachment located on the International Space Station and Lunar Gateway, thus reducing the need for human involvement. Next, we look at Cartesian robots. A Cartesian robot, also known as linear robot or gantry robot, is a robot that uses the three-axis system, the X, Y, Z of Cartesian coordinates. These robots are popular for a variety of tasks, like pick and carry and loading, but there's one task that has blown up in popularity: 3D printing. 3D printing is one of the most popular applications to enter the construction industry. This is due to the ability to create a variety of products, including a 3D printed home. The quick, efficient, and affordable way of 3D printing a home may very well make traditional home building a thing of the past. Collaborative robots are also getting popular. Collaborative robots, also known as cobots, are robots that are designed to work alongside humans, performing tasks that would otherwise be too difficult for humans or robots to do alone. The consistent labor shortage is an unfortunate trend in the construction industry, but cobots may be used to ease that burden and one day replace the human labors for low-skill work. SCARA is an acronym that stands for Selective Compliance Assembly Robot Arm, or Selective Compliance Articulated Robot Arm. SCARA robots functions on three axes, the X, Y, and Z, and have a rotary motion as well. SCARA robots excel in lateral movement and are commonly faster moving and have easier integration than Cartesian robots. Typically, SCARA robots are used for assembly and palletizing, as well as in biomedical applications. Cylindrical robots. These robots have a rotary joint at the base and a prismatic joint to connect the links. The robots have a cylindrical shaped work envelope, which is achieved with rotating shaft and an extendable arm that moves in a vertical and sliding motion. Cylindrical robots are often used in tight workspaces for simple assembly, machine tending, or coating applications due to their compact design. Delta robots or parallel robots possesses three arms connected to a single base, which is mounted above the workspace. Delta robots work in a dome shape and can move both delicately and precisely at high speeds due to each joint of the end effector being directly controlled by all three arms. Delta robots are often used for fast pick and place applications in the food, pharmaceutical, and electronic industries. Polar robots or spherical robots have an arm with two rotary joints and one linear joint connected to a base with a twisting joint. The axles of the robot work together to form a polar coordinate, which allows the robot to have a spherical work envelope. Polar robots are credited as one of the first types of industrial robots to be ever developed. Polar robots are commonly used for die casting, injection molding, welding, and material handling. The popularity of drones in the construction industry has been increasing, and it's very easy to see why. Their versatility on the construction site helps with safety and progress throughout a project. As they are remotely controlled with aerial capabilities, these machines are uniquely able to provide real-life update on a construction project, thus revolutionizing the way the project is constructed, and typically it reduces the need for human laborers. As the industry continues to grow and innovation continues to increase, the use of drone in the construction industry will only continue to increase. One common use of drone is to produce a 3D mapping of the surrounding project site. That is done where the drone can produce a detailed aerial map of the work site, which can be turned into a 3D model. This allows contractors to point out and plan for potential challenges during the planning process. This can provide a more accurate budget estimate, saving money in the long run. Drones can also be used for remote monitoring and inspecting the work sites. Instead of renting a boom lift or large crane that requires more than one person to operate, drones can provide crucial inspection without the hassle. A drone's aerial ability allows it to inspect hard-to-reach places. Drones can also be used for maintaining securities on site. Security is one of the most important aspects on a construction site, with theft costing the industry anywhere between $300 million to $1 billion a year, with less than 25% of the amount being recovered. Humans are only able to do so much, but with drones, security can be easily improved. A single drone operator can fly the drones up in the air to take an aerial view of everything, and thus improving the security for the site.